Welcome to series of database management lectures. Today we'll be discussing about Unit 2, Topic 4, that is Extended Entity Relationship Model. So, in the previous sessions, we have already discussed about what is entity relationship, what is the use of defining an entity relationship model. And we have discussed various examples such as student management system, employee management system, library management system, right? So all those were the examples, and we have learned how to design an ER model and how to convert this ER model into a relational scheme. Now, when we wanted to design a real world scenarios, then then entity relationship model will not be up to the mark in specifying new set of constraints. So that's how extended ER model has been developed. So this model helps us to design an ER model which can benefit to even new generation of constraints as. Now when we wanted to utilize the existing entity model which is already available, then in that case, instead of redesigning everything from scratch, we can simply acquire the qualities or the features from the existing relational model. So that sort of thing can also be modeled in this extended entity relationship model. All the complex designing of the database systems are very easily developed using extended entity relationship model. Now, let us look at these enhanced entity relationship model with the help of few concepts. They are subclasses and then superclass. Let us see what do you mean by subclass and then superclass. What do you mean by subclass and then superclass? If an entity which is already defined, an entity which is already defined with few set of attributes. Let us take an example of a person. So here in person entity, we can define the attributes to be person name and then person to be identified uniquely using PID, which is a key attribute. Okay. And then gender. Now, at later stage, now I wanted to develop my database which can fit to only the employees. Now, I need similar kind of information, that is name, ID, and gender. Apart from this, I wanted to have additional qualities or the attributes for this employees. So in that case, I need not redefine these three attributes separately. Instead, I can just create a subclass type to this particular person entity. Now, employee entity will acquire all the qualities of the person entity. Now, by default, all these three attributes will be available for this employee entity. Now, we need to just assign only the employee specific information only. That is, employee is working in which particular department, what is the salary for the employee given, and what are the additional allowances that are offered, right? So this is what called as reusage, reusing the existing entity and extending it to the further case. So in this context, this person can be called as a superclass entity, whereas employee can be treated as subclass entity. So this kind of complex designing or modeling of an entity relationship model helps us and can be applicable to any sort of extent. The next one is specialization and generalization. Now, specialization and generalization are much more similar to the superclass and then subclass, right? So here, generalization tells us that a very common features can be specified here. Common qualities or the features are defined here. Specialization will be focusing only on very specific qualities or the features. So specific qualities are going to be mentioned here. Now, let us take another example. Or let us continue with the same example. Now, in this context, person was an entity which we have defined, right? And then employee. Now, employee was the other subclass type of an entity. Now, later, I wanted to develop a student database. In this context, I need similar kind of attributes which were already defined by the person superclass entity. That is PID, PNAME, and then gender. So these common attributes can also be extended further to the more specific one. Now here, person is a student. Now I can be more specific to define only student data here. So student will have ID, name, and then gender. Apart from that, I can even add class to which he belongs to, college name to which he belongs to, and then academic related information such as subject marks. Okay? So these are more specific to the student. Now, in the other aspect, person can also be an employee, but here employee subclass type can have these three attributes, that is PID, PNAME, and gender. In addition to it, it can also have salary and then allowances and then work type, whether hourly basis or the day type, temporary or permanent. So here, entity of person type can also be a student, can also be employee, which can be more specific. Now, when it comes to employee, you can have the next version of subtypes as well. So here you can define is a part-time employer, whether the employer would be a part-time employer or full-time employer, right? We can even define such kind of entity, part-time employer, full-time employer, right? So in this manner, you'll be able to, when you start from topmost point and going down to the structure, then it is going to be more specific to the context. And when we are going from bottom to top approach, then we will be focusing more on general concepts. We are going to more common specific, more common features. Okay. And the third one is category or union type. Now, category or union. Category can also be taken as whether this particular Now let us take other example, that is vehicle is a vehicle could be a car, vehicle could be a truck, vehicle could be even a bicycle. So here now we'll discuss category or union. Now we have an entity called as owner entity. Owner will have name. Owner will have a location or a place where he or she belongs to, right? And what are their identification details? Okay, identification details. Now, this owner can be taken as a union type for an owner could be for a vehicle car, or an owner could be for a house entity or for a car entity. These two are also real world objects. So that's how this owner is more possessive kind of things, and it can be applicable to the vehicle or to the building as well, right? Next is aggregation. Now, when it comes to aggregation, we have two things. One is total participation and then partial participation. What do we mean by total participation? Now, when an entity A is defined, when an entity A is defined, which can have, when an entity A is defined, and we are defining another entity called as B. If B is an entity which contains the information about A as well, then it is called as aggregation. So, in common to both A and B information can be retrieved from this. So, this is called as total participation. So, now you will be able to retrieve the complete detailed information about B and A together with the help of this entity. Now, partial participation is that non-identifying attributes, non-identifying entities. Now, A is an entity which is defined and B is another entity. For both, we have defined a relationship called as talks. Both are related with associated with each other. Now, when B entity do not maintain any identifying features from A, then we can say that this is non-identifying entity and the previous one is identifying entity. Now, aggregation puts all together so that you will be able to retrieve the complete detailed information. Now, here in this relationship talks, you will have all the information about the ID information about A as well as B. The relational schema can be defined in such a way that talks relationship associated with both A and B is maintained. So this is what called as aggregation. So you will be able to apply the same thing for an employee and then work. So employee works for the company. Just a clear relationship. Employee works for the company. So this is an association made between employee and then company. So works is a relationship which will give the information about the employees who all are working under the company. Right? So it is works is an aggregation of both employee as well as company. Right? So these are, apart from routine entity relationship model concepts, extended entity relationship model allows us to develop complex real kind scenarios of the ER models, and you'll be able to design any complex structure of the database which can satisfy the real needs of the representation. Right? Thank you.